Okay, by now you should be pretty used to using the phet simulator, and you do have a big experiment that you're going to kind of walk through. It's got a lot of questions. It's step by step. I'm not going to lie, maybe my wording wasn't the best, but you're going to be using this simulation to gather data so that you can derive the equations that link the relationships of current, resistance, and voltage drops in both series and parallel circuits. So to gather data, it's pretty simple. You're going to set up the normal experiment like you would. So I'll just do a battery and a wire, and a wire and a light bulb and all sorts of fun stuff. Woo! And there we go. All right, so now in the experiment, you're going to be asked to gather data on the voltages as well as the currents across different things. Okay, so let me show you how to do that, just so there's no confusion. First thing I do recommend to include the values, because you will be asked, or I guess told, at the very beginning of each section on how you need to set this up. So in order for this to be clear and easy numbers for you to manipulate, you want to make sure that you are changing the things to the correct resistances and the correct voltages. Okay, so I think like instead of 9, maybe it says 100. So you just gotta, crank it up to 100 volts or 10 volts or something like that. So just make sure that you're setting it to the appropriate values that are being asked for you. To take your readings, you need a voltmeter. This is going to tell you your potential differences across. Okay, and so all you have to do is just put it on both sides. To be perfectly honest, it does not matter the order that you have it in. All that's going to happen is you're going to have a negative voltage or a positive voltage. Always just take the absolute value. Okay, so you're just taking the voltages, just worry about the absolute value at this point. Technically, if you are to do this correctly, then the battery should always have a positive, and all of the bulbs or resistors should all have negatives, because I'd have to flip this around. Because the battery is basically giving energy to the system and the light bulb is taking energy out of the system. That's why this is referred to as a voltage gain, and this is referred to as voltage drops. So that's one thing. But basically, we're just going to look at, hey, let's look at these absolute values, and hopefully they'll make sense. So that's your voltages. You can do it between any 2 points you want. Okay, I usually put it at these like junctions, nodes. Also, you're going to need to take currents. For this, you might as well just use the non-contact ammeter. It's just easier. And you just put it across any wire that you would like to have the current for. Okay, you could use the regular ammeter, but if you notice, the electrons are in between it. So if you do want to use a regular ammeter, then you have to physically put it in between the different objects, and you'll see that the electrons flow through it. And so, if you want, you can put a bunch of them out there. So you could have a bunch of different ways to move out of my way, a bunch of different ways to evaluate the current. You could see at different locations all at the same time if you want, totally fine. Or you could use your non-contact ammeter and just have it read out the values for you as you move it around the experiment. So those are the main things that you're going to be using to collect data. But again, don't forget, before you start this, you're going to want to click on the light bulbs as well as the battery, and you're going to want to adjust the voltage or the resistance based on what is basically asked of you. Also, you'll be talking about schematics, and if you want, you can look at this in a schematic mode, and you can see the symbol for my brain just died, a battery and a resistor. Okay, a light bulb is technically a different symbol, but again, as I've mentioned earlier, it acts almost identical as a resistor. Okay, it still uses up energy. It's still an energy sink. The only difference is it doesn't glow. Okay, a resistor does not glow, whereas a light bulb does. But they are effectively the exact same thing. So usually in all of our symbols, we will draw the picture of a resistor. I recommend this just because you get that good visual, and it's pretty. So yeah, so hopefully that'll help you when you're going to do the experiment and collect actual numeric data on how this works. So that's been great, and I will see you guys on the flip side. Enjoy your science.